So I kind of want to bring it back around to what Hadley was talking about at the start of the day, when she was kind of talking about when the web was born, right? It's, 25 years ago now, Tim Berners-Lee created the World Wide Web. I have to point out, by the way, this is the World Wide Web when it only exists on one computer, but he still called it the World Wide Web. And you have to admire the confidence in that. And like Hadley was saying, the environment in which the web was born was maybe different to the one in which it's evolved today. It was born in this environment, CERN. CERN is just an amazing place, right? Underneath the border of Switzerland and France, you've got this giant machine, the Large Hadron Collider, the largest machine ever built by man, recreating conditions from the start of the universe, hurling these photons together. It's just an amazing place. And people from all over the world are there, and they're collaborating, and there isn't much of a hierarchy system at CERN, right? You've got Nobel Prize-winning physicists, you've got students on summer internships, and they're collaborating together on these experiments. And when it comes to data formats and storing data and communicating information, you don't get to dictate to these people, oh, you have to use this operating system or you have to use this particular format. People will use whatever they want. And this was the issue that Tim Berners-Lee was trying to tackle, right? Managing all this data. And he settled on using a hypertext system. Now, he had previously experimented with a hypertext system before. About 10 years previously, he had a system called Inquire. It was named after this Victorian book of manners called Inquire Within Upon Everything, which I always thought would be a great name for the World Wide Web. Inquire didn't work out too well, but he took a second stab at it while he was at CERN, and he submitted this paper to his supervisor, Mike Sendall, and it doesn't have the best title, right? It's a bit boring, Information Management, a Proposal. But Mike Sendall must have seen something in this proposal, because he scrolled across the top, vague but exciting. And so Tim Berners-Lee gets to go ahead, and he creates the World Wide Web. And one of the things he realized right from the start was, it couldn't be hard to get started with. It had to be familiar to people. And that meant making it as simple as possible. I mean, it's built on top of the internet, and it's kind of part of the ethos of the internet too, right? That it's really, really simple. That, the network doesn't care about the contents of the packets that it's switching around. It's just trying to get packets from A to B, right? It's a dumb network. And that design of not being smart turns out to be the secret sauce of the internet. And I think that, Tim Berners-Lee took that on board with the building blocks of the World Wide Web, right? HTTP is the protocol sitting on top of TCP/IP. You got URLs as identifiers built on top of DNS system, right? And HTML. And all of them, they're okay. None of them are great. They're not the best formats. They're not the best protocols. But they're simple enough and yet just powerful enough that people could get started quickly. I mean, HTML, classic example, at the beginning, there was never a version 1 of HTML. There was just this document called HTML tags, presumably written by Tim Berners-Lee, that documented the entirety of HTML, which was 21 elements. And even those 21 elements, Tim Berners-Lee didn't invent. He just borrowed them wholesale from the version of SGML that was already being used by the scientists at CERN. So it was familiar, right? He understood that to get people using a technology, nudge their behavior rather than trying to get them to change their behavior completely. Now here we are, all these years later, and HTML5 has got 121 elements at last count. And how is this even possible? That it's still the same format, right? It's still HTML. It's grown by 100 elements over more than 2 decades. And yet it's still HTML. This kind of blows my mind, because if you know anything about computer formats, this is very long-lived. If you tried to take a word processing document from 20 or 25 years ago and run it today, you're going to have a bad time. And yet you can take the very first website and look at it in a modern browser. That's kind of amazing. I think the reason why HTML has been able to grow, and the secret to the longevity of HTML, is down to a design decision in how it's parsed. So let's say you give a browser an HTML element, right? You've got an opening tag, and there might be some attributes on there, maybe not. You've got some content, you've got a closing tag. Now, the content in between the opening and closing tags gets rendered, and maybe something extra will happen depending on the element in question, right? Some user agent styling, maybe in the case of form elements, images, links, there's some particular behavior. But the main thing is that you give a browser an element like this, and it displays the content in between the opening and closing tags. Okay, you all know this. But here's where it gets interesting, is if you give a browser an element it doesn't understand, an element that doesn't exist, so it still renders the content in between the opening and closing tags. It just ignores the tags and renders the contents. See, why this is interesting is what the browser does not do. The browser does not throw an error to the user. The browser does not stop parsing the HTML at this point and refuse to parse any further. It just skips the tags it doesn't understand, renders the content, and carries on. So very, very lax, loose error handling. And that's exactly how we've been able to add extra elements to HTML over time. We know exactly how older browsers are going to behave. They'll just render the content and ignore the tags they don't understand. We can use this to our advantage, right? If we know that older browsers are going to render the content in between the opening and closing tags, then let's say, okay, well, newer browsers don't render that content, and that's where we can put the fallback content for the older browsers. Like, that's how Canvas works, and that's not an accident. You know, when Canvas was first invented, it was a proprietary element created by Apple. Other browser makers saw it and went, ooh, that's nice, we'll have that. And it got standardized. And when it got standardized, the closing tag was added specifically so that we could do this, specifically so that we could add fallback content for older browsers. So it's a deliberate design decision that HTML has this loose error handling. And it's a similar situation with CSS. Now, if you stop and think about all of the websites out there using CSS, which is basically all of them now, right? How different they look, you know, the different designs, the different styles, and then think it all actually comes down to just one pattern. You got a selector, property, value. That's it. That's all the CSS that's ever existed, all the CSS that's ever been written. I find it, you know, kind of beautiful that it comes down to such a simple pattern. Yeah, we got these special characters, curly braces and stuff for the machines to parse this, but basically this is it. This is CSS. Of course, the tricky part is knowing the vocabulary of the selectors and the vocabulary of the properties and the vocabulary of the values, but the underlying pattern is really simple. And if you give a browser a selector it doesn't understand, well, it just skips over the curly braces, right? It just doesn't match that selector. It does not throw an error. It does not stop parsing the CSS file at this point. Give it a property it doesn't understand, it just skips to the next line. Give it a value it doesn't understand, it just skips over what it doesn't understand. And so we've been able to add to CSS over time, right? Add more selectors, more properties, more values. But when I think about, you know, how CSS has changed in the last, say, 5 years, I'd say, you know, the biggest changes, probably, well, there's two of them. One is the fact that we use things like pre-processors and post-processors, things like less and Sass. Who's using something like Sass, some kind of pre-processor, post, right? Most people are writing CSS. And the other thing is that we have these, you know, systems of how we structure our class names, things like object-oriented CSS and SMAX and BEM and all the other ones out there. Who's using some kind of naming system like this, like BEM or something? Right, quite a few. See, what I find interesting about both of these is that in neither case did we, developers, authors, have to go lobbying standards bodies and browser makers saying, oh, please implement this into the spec. Right? We were able to just do it. In the case of preprocessors, because it sits on our own machine. And in the case of these kind of systems of naming things, it's because we're really just talking about selectors, right? How we name classes. And I find that interesting because even though we've only been doing this for maybe the last 5 years, selectors have been around since the start. So, you know, there's no reason why we couldn't have been writing BEM 15 years ago. It's like it was there, hidden in plain sight, right in front of our face, and we didn't see it. That's something I want to come back to. So, CSS and HTML have grown over time in a sort of safe way, a backwards compatible way, because they have this loose error handling. And to me, I think that the way the browsers treat CSS and HTML is an example of the Robustness Principle, also called Postel's Law, that you be conservative in what you send, you be liberal in what you accept. Now, John Postel, he worked on the internet, on the DNS system, and he was talking about packet switching, right? That be conservative in what you send. If you're going to send out a packet, make sure it's a well-formed packet. But if you receive a packet and it's badly formed, but you still understand what you're supposed to do with it, well, just do that. Don't be a dick about it, right? Don't say, oh, I refuse to pass on that packet. Be liberal in what you accept. And you might think this is a very technical kind of law, this robustness principle, but I see it all the time. I see it in the world of design and user experience. Let's say you're putting a form on the web. Well, classic, you know, first rule is use as few form fields as possible, right? Don't make it really long. Make it as short as you can. In other words, you know, be conservative in what you send. But then when the user's filling out the form, don't make them format their telephone number a certain way or their credit card number with spaces or without spaces. Be liberal in what you accept. So Postel's law, I kind of see it all over the place, and I certainly see it in CSS and HTML. Now, I think that one of the reasons why CSS and HTML can afford to be so liberal with their error handling is because they are declarative languages, right? So with CSS and HTML, you do not tell the computer line for line exactly what it's supposed to render to the screen. It's more like you're declaring what you want. This is my content, these are the styles I want, and you leave it up to the browser to do the rendering, right? That's different to an imperative language. Like in the browser, we have JavaScript, and JavaScript is imperative, where you have to tell the browser exactly what you want it to do, right? Now, of course, you get so much more power with an imperative language because you have that control. Much more power than you get with a declarative language. But the declarative languages, well, A, they tend to be a bit easier to learn, right, because they're declarative. And B, they can afford this lax error handling. You can't really do that with an imperative language, right? It wouldn't be helpful if you're trying to program in JavaScript and there's an error and the browser's like, don't worry about it. You know, that's not useful. But what this does mean is that because of the loose error handling, and this is a broad sweeping statement, but I would say that declarative languages like CSS and HTML tend to be more resilient, precisely because they're loose with error handling. Whereas an imperative language, like JavaScript in the browser, even though it gives you so much more power, is inherently more fragile because its error handling model is different. If there's an error in your JavaScript, or you give the browser some JavaScript it doesn't understand, it will throw an error, and it will stop parsing the JavaScript file at that point and refuse to parse any further. Now, interestingly, about 10 years ago, we almost got the worst of both worlds. Trigger warning, XHTML2. So this is when the W3C had decided, oh, HTML is dead, XML is everything, so we're going to reformulate HTML as XML, right? Now, to begin with XHTML1, that was fine, because we were really just taking the syntax of XML, which was, you know, all your attributes must be quoted in lowercase, your tag names must be lowercase, right? Because in HTML, it doesn't matter. Uppercase, lowercase, quoted, unquoted. Browsers don't care. They're liberal in what they accept. So it was actually kind of nice when we switched over to XHTML1 because it was enforcing a kind of a coding style in HTML. XHTML2 was a different beast because instead of just borrowing the syntax style of XML, it was also going to borrow the error handling model of XML. And the error handling model of XML is this. If there is a single error in the XML document, do not parse the document, right? So if there's one unencoded ampersand in your XHTML2 page, you get the yellow screen of death, right? Now, this, of course, is ridiculous that you would ever put something like this on the public web in front of users where it was so fragile, right? And we, developers and designers, we roundly rejected it. We were like, no, there was this rebellion. We got HTML5 so we could keep going with HTML. We rejected this draconian error handling model. And yet, here we are, 10 years later, and suddenly it's like, no, I'm going to render text to a screen using the most fragile layer of the stack. What could possibly go wrong? Somehow we've decided now it's okay to make sure that, you know, the piece of the stack with the most fragile error handling is the one we're relying on for everything. Like I remember a few years ago, the page for downloading Google Chrome had a JavaScript error in it, and nobody could download Google Chrome. That's because the link to download Google Chrome wasn't a proper link to a URL. It was using the JavaScript pseudo protocol. So it's like taking the fragile layer of the stack and pushing that down into the imperative layer, or the declarative layer. It's like, again, the worst of both worlds. Now, this brings up another law that I think on the web is as important as Postel's law, and that's Murphy's law. Murphy was a real person. He was an aerospace engineer, and because of this attitude, nobody died on his watch. Anything that can go wrong will go wrong. It's an uncomfortable truth, but it's something I think we should accept on the web, right? And especially when it comes to something with a fragile error handling model like JavaScript. Stuart Langridge put together this kind of list of all the things that could possibly go wrong with JavaScript. And some of it's on the client, some of it's on the network, some of it's on the server, but they're just things out of your control. You can write the most perfect JavaScript and something can still go wrong. Something can go wrong with your HTML and CSS too, but because of the error handling model, it doesn't matter as much. It's more likely to recover. You know, it's like It's like when other industries, prepare for the worst, right? They imagine what's the worst that could happen, and they test for that. Car manufacturers strapping in crash test dummies and smashing them against walls at high speed. Could you imagine if one day they said, yeah, actually, no, we've been thinking about this, and we're not going to strap crash test dummies into cars and smash them against the wall at high speed because we realized that actually these cars are going to be driven by people, not crash test dummies. Also, we anticipate these cars will be driven on roads rather than smashed into walls at high speed. Well, yes, of course. We all hope that that's what's going to happen. But, you got to hope for the best, but prepare for the worst. My friend Trent Walton talked about exactly this. He said, like cars designed to perform in extreme heat or on icy roads, websites should be built to face the reality of the web's inherent variability. This is what makes the web different to other media, the reality of the web's inherent variability. We need to face it. Okay, this sounds very gloom and doom, right? They come here and say, well, no matter what we do, we're doomed. Don't use JavaScript. That's not what I'm saying. I'm not saying that. Far from it. I'm saying it's about how we use these technologies. And I give you a solution. It's a 3-step program to building websites that means we can do it in a more resilient way. And here's how it works. First of all, identify the core functionality of what it is you're building. Just the core functionality, not everything, just the core functionality. Then you build that. You make that functionality available using the simplest possible technology. Not the best technology, the simplest technology. Then you enhance, and that's where the fun is, right, at the third step. So let's talk through this 3-step process. Identifying the core functionality. This is kind of like setting your baseline of what you need people to be able to accomplish on your site, what you want everybody to be able to do on your website. So let's say you're a news provider. What's the core functionality? Well, it's right there, right? Providing the news. Not mentioning any technologies yet, we're just talking about the functionality. Providing the news, that's the core functionality. Let's say you're a social network where people can send and receive messages from all over the world. Well, I would say that's the core functionality, the ability to send messages, the ability to receive messages. Again, we're not discussing technology yet. If you've got a photo sharing site, well, the clue is in the name, the ability to share photographs. Again, I want to see photographs, I want to share photographs. And let's say you've got this online collaborative tool where people can write and edit and share. There we go. That's the core functionality, right? Writing, editing, sharing. OK. We've established the core functionality. Now, how do we make that functionality available using the simplest, not the best, the simplest possible technology? Well, in the case of putting the news online, I'd say HTML, right? I'll mark up that news in an HTML document. Now, technically, actually, I would say that the simplest possible technology would be a plain text file. But I'll allow myself, some HTML in this case. Done. OK, I need to be able to see messages on the social network, probably in a reverse chronological order. OK, that's what we've got a list for. And I need to be able to send a message to the server. So a form field, input type equals text. Send it to the server, full page refreshes. There we go. In the case of photo sharing app, it's very similar. That reverse chronological list now probably contains images rather than just text. And the form field this time is a little different. Instead of input type equals text, it needs to be input type equals file so that I can send an image to the server. And in the case of that collaborative writing tool where you can write and edit and share, the text area. All right. Now, if you stopped at this point, I wouldn't hold my breath waiting for the IPO. Let me put it this way. Technically, what you've built works, but it kind of sucks, right? The UX is terrible, full page refreshes for everything. It's not fun to use, but it is accessible to everyone because you've built it with the simplest possible technology. Now that you've done that, now that you've laid this baseline, the fun you'll have at step 3 where you enhance. So in the case of this newspaper article, I've put it online as HTML. I'll lay it out on wider screens. It might be weird to think of layout as an enhancement, but if you think about responsive design, and particularly mobile-first responsive design, well, that's exactly what layout is, right? You have your regular styles, and then inside your media queries, you got the styles for larger screens. Layout is an enhancement. When I say something is an enhancement, please don't misinterpret that as me saying it's just an enhancement. The enhancements are what matter. The enhancements are what differentiate you from the competition, right? So we can have layout, and we can have beautiful typography, like we heard about earlier from Helen, right? With font face, with web fonts, when done responsibly, we can make it beautiful. In that social network, like I said, it's full page refreshes. It's not a great experience. Well, let's use Ajax so that when I post to the service. I don't have to have a full page request. In fact, let's make it so that when messages arrive, I don't have to have a full page request, right? We can use something like WebSockets. Maybe it's not supported in every browser. Doesn't matter, because the core functionality is available for everyone, no matter what kind of browser they have, right? Everything from here on in is an enhancement. Now, for this photo sharing site, we'll use all the previous things we've said, right? Layout, font face, Ajax, WebSockets. Let's have some more fun. Let's use something like the file API, right? We can get that image into the browser and do fun stuff, like put CSS filters, put a sweet sepia tone on that photograph, right? Again, maybe it's not supported in every browser. That's OK. The core functionality is supported in every browser. And in the case of this online writing tool, everything we've said so far, right? The Ajax and the WebSockets and the layout and the web fonts, all that stuff. But let's use some sort of local storage. And boy, have you got a lot of choices when it comes to local storage, right? To make sure that the data isn't reliant on that network connection. And of course, we can have service workers. Beautiful, beautiful service workers. You're going to be hearing a lot about service workers. Tomorrow there's a whole discussion on progressive web apps, right? Call it what you want. It's about service workers. It's probably the web technology I'm most excited about right now, because we can effectively make the network itself an enhancement, right? This is true resilience. When you're creating something on the web that once the user's visited it, still carries on working even if the network is flaky. So powerful. So you see, with this three-step process, you get to have your cake and eat it too. I want to put an end to this false dichotomy that you can either have something simple that works everywhere, or you can have some rich, immersive experience for the latest and greatest browsers. No, I'm saying you can have both. You can have both if you build in this order. Don't jump to step 3. Now, what I like about this three-step process is it's kind of scale-free. It works at different scales. I've only been talking about the whole system, right? The whole service you're building. But you could imagine doing this at the level of a single URL. Right? What's the core functionality of this URL? How do I make that core functionality available with the simplest possible technology? And then how do I enhance? What's the fun stuff I can do? Go further. You could imagine doing this at the level of a component, a module. What's its core functionality? What's the simplest possible technology to enable that? And then how do I enhance up from there? So the way I think about this, about spending a little time in steps 1 and 2 before jumping to step 3, is we heard earlier on today about all the dangers with frameworks. You end up inheriting technical debt, right? Well, I think of this as technical credit. What you're getting here is you're getting permission to kind of go crazy at step 3. And there's a bit of a myth about this approach that, if you're thinking about how it's going to work in older browsers, that means you're spending all your time in older browsers. No, it's the exact opposite. Because I spend some time making sure, there's full page requests that still work, client server, and then I go and enhance with all the cool JavaScript stuff, I've got carte blanche to go crazy with the latest and greatest APIs. It's kind of the only responsible way to start using this stuff today. It doesn't matter if on Can I Use there's only one column of green, you can still start using this stuff. So far from me saying that, I'm here to spread doom and gloom and say you can't use this or you can't use that. I'm saying you can go crazy as long as it's step 3, right? That you've already built the technical credit of steps 1 and 2. But I don't see sites, web apps being built this way. And I worry, why is that? And I can't help but come to the conclusion that the reason is that we collectively have kind of come to believe that developer convenience is what's most important when it comes to evaluating technologies. How is this going to make my life easier? Now, don't get me wrong. I'm a big fan of developer convenience as a developer, right? I want my life to be as easy as possible, but not at the expense of user needs. That's got to come first. It isn't about us. It's about them. If I have a problem, and I'm given the choice of making it my problem or making it the user's problem, I'll make it my problem every time. Because that's my job. That's why I get paid. That's why they call it work, right? And yet I find that we collectively, we're always complaining about what we don't have. Like, making my life easier, right? 20 years ago, it was like, the web will be so much better when we have more than 216 colors. True story, 216 colors, right? The web will be so much better once we have, web fonts rather than these system fonts we're stuck with. Things will be so much better when people will finally upgrade from Netscape 4. If those Internet Explorer 6 users would just upgrade, everything would be fine. If people would just get off Windows XP, then the web can move forward. If those Android 2 point whatever users would just upgrade, right? There's always something. We're never happy. My friend Frank, he wrote this essay called there is a horse in the Apple Store. And in this, he describes the true situation of the horse in the Apple Store. Tiny horse. He describes the horse in the Apple Store, and he also describes the reaction, or complete lack thereof, by all the people in the Apple Store looking at the new shiny stuff. Like, there's a horse in the Apple Store. And he's taken to calling this kind of stuff, you know, stuff that's right in front of us, that's amazing, it's a miracle, and we don't even recognize, we don't even see it. He calls them tiny ponies. And I think the World Wide Web is a tiny pony. Right? It's an amazing thing that we take for granted. We're always comparing it to other things, CD-ROMs, Flash, now native, and seeing what those things can do that we can't do without realizing what only the web can do. Right? The greatest distribution platform ever. That with URLs, not only can you put something up there now, you can make it last over time. You can contribute to the next generation. Right? That with URLs, we can extend the reach of our networks for future generations. We can extend the reach of the collective knowledge of our species. You know, it's a heavy responsibility, but I kind of think we need to be good ancestors building on the web. So let's leave behind a web that lasts, a web that's resilient. Thank you.